Okay, so in this video, we're going to be looking at writing equations of a line that go through various points, have various slope properties, and so on. So we're going to do several worked examples that start with different properties. So the first one is we're going to start with find the equation of a line that passes through 2 points. So the 2 points that we're going to use, I'm just going to come up with randomly, -4, 2, and 1, -1, 1. All right, so the first thing you have to do when you have 2 points is to find the slope, because there's 2 things that you need when you create an equation of a line. You need the slope and you need a point. So first thing we have to do is we have to find the slope. So in this particular case, the y coordinates, we're going to have, if I go from right to left, 2 - 1, and then the x coordinates are going to be -4 minus a -1. So my numerator is going to be 1, and my denominator is going to be -4 plus 1. Be careful with these multiple signs. Which is going to give me 1 over -3. So -1/3 is my slope. Now, once I have the slope, then I can put this information into one of our line equations, either the point slope form or the slope intercept form. I prefer the point slope form because you're constantly working with an equation, and students don't make the mistake of solving for B and then quitting, or putting in the points and then not solving for B either. So what we're going to do is we're going to use the point slope form. And just as a reminder of that equation, it's y minus y1 is equal to mx minus x1. So y1 and x1, well, x1 and then y1 is one of your coordinate points. You can use either one you want. And then m is the slope. And then x and y stay in the equation as variables, so that when you get to the end, you have an equation. So we're going to plug in y minus, I'm going to use the smaller coordinate points just because they're a little easier to work with usually. Y minus 1 is equal to -1/3 x plus 1, because it's a minus 1 in this point. But as I said, you can use either point that you want because they will get you to the same place. Now we distribute y minus 1 is equal to -1/3 x minus 1/3. And then we're going to add 1 to both sides of the equation. One is 3/3. So our final equation is going to be y is equal to -1/3 x plus, so -1/3 plus 3/3 is going to give me +2/3. So this is my equation of the line. You can stop here if they don't specify what kind of format. If they ask you to put it in standard form, you need to put x and y on the same side of the equation. So that would be 1/3 x plus y equals 2/3. And occasionally they will tell you to get rid of the fractions, in which case we multiply everything by 3, and then we get this equation. So that's the equation in standard form. This is the equation in slope-intercept form or function form. If you replace y with f of x, this will be function form. All right, so let's try another example. Sometimes you'll get lucky. Write the equation of a line with a given slope and passing through a given point. In that case, if they just give you the slope, then you don't have to find the slope. So that will go faster. And the point is 7, 1 in this case. Now, again, if they give it to you, then all that slope stuff that we solved because we had 2 points and no slope, we don't need to do. Now I will show you for this example what happens if you just use y equals mx plus b, and then how to get to the end. Because again, that last step is usually the thing that students will forget. So if I start with y equals mx plus b, then I would plug in my point and my slope in order to find b. So y is 1, m is negative 3 over 5 times 7 plus b. That's going to give me negative 21 over 5. And so then I'm going to add 21 over 5 to my other side of the equation, which is going to give me 26 over 5. Since 1 is 5 over 5, 21 plus 5 would be 5. It would be 26. Okay, so now that I have my b, now I have to rewrite my equation as y equals negative 3/5 x plus 26 over 5. Now, I can also use the point slope form. The point slope form would have me start with y minus 1 is equal to negative 3/5 x minus 3/5 x minus 7. And then I would distribute y minus 1 is equal to negative 3/5 x minus, plus 21 over 5. And then if I add 1 to both sides, I end up with the same intercept that I ended up with before. So both of these processes will get you to the correct answer, and you should use the one that you feel most comfortable with. But when you're using the point slope form or the slope intercept form, do not stop at b. We're very used to solving equations in algebra, and we get, oh, the variable b, I'm done. No, because you're trying to find the equation of a line, not the value of the intercept. So always a good idea, go back and reread your question to make sure you know what you're solving for. And then similarly, if I wanted to put this in standard form, as with my previous example, I move the x over to the other side. And then I multiply everything by 5 to get rid of the fraction. All right, now, what if you're given information about parallel or perpendicular lines? Find the equation of a line parallel to a given line and passing through a given point. So in this case, then, let's say I have the equation y equals negative 3/2 x plus 6, and I want to pass through the given point, let's say 6, 5. Now, for a parallel line, a line parallel to the one that's given, then the slopes are going to be the same. So both slopes for both equations will be the same, in this case, negative 3/2. Then you're going to take the point that you have, and now that you have a slope and a point, you're going to put them into one of our line equations. Again, I'm going to go back to the points slope form. So this will be y minus 5 is equal to negative 3/2 x minus 6. And then I'm going to distribute. Minus will give me a plus. 2 will cancel with the 6 and leave me a 3. So this becomes a 9. And then I add the 5 back to the other side. 9 and 5 is 14. Notice that I have basically the same equation that I had before, except that the intercept is different. Again, it's a parallel line, and the gap between them is constant all the way around. Now, what if the line is perpendicular to another line? Find the equation of a line perpendicular to a given line and passing through a given point. So let's say I have the line 4x minus 7y equals 11, and passing through the point -4, -8. Now, when you're given an equation of a line and you need a slope out of it, but it's in standard form and not slope-intercept form, you have to solve for y. So so I'm going to move the 4x over to the other side. So 7y minus 4x plus 11. Then I'm going to divide everything by -7, and that's going to give me positive 4 over 7 minus 11 over 7 x. So my slope of the given line, we'll call it M1, is 4 over 7. But the relationship to a perpendicular line is not identical. It's the negative reciprocal. So M2 is -1 over M1. Now that means in this case that my second slope is going to be, and since it's already a fraction, I'm not going to put it in a fraction. I'm just going to take the reciprocal. So it's going to be -7 over 4. So flip the fraction and flip the sign. Now we have our slope and we have our point. So now we can go to our point slope form. So y plus 8 is equal to -7 over 4, x plus 4. We distribute -7 over 4x minus, the 4's cancel, and I'm left with -7. Yes, -7. And then I subtract the 8 to get rid of it on this side, move it to that side. Y equals -7 over 4x minus 15. And then again, I could rearrange this, put it back in standard form, but for right now, I'm going to leave it the way it is. The thing to keep in mind is when I solved this one and I solved this one, the constants are not the same. You can certainly keep the constant if you're only making it perpendicular, but not worrying about what point it passes through. But if it's passing through a particular point, the constant in the two equations is almost never going to be identical. And so it's important that you actually go through, find the new slope, and then solve for the new constant.